Man, we're back and better than ever. These notes, first ones of the 2017 calendar year. These would be if you are an A day. This is January 5th. If you are on B day, 1B, this would be January 6th. However, you're 3B or 4B due to the snow day that we had to lead out early. This would be January 10th. We're still looking at trigonometry. We're talking about sum and difference formulas. And we have three main sum and difference formulas. I already gave tangent here. I'll get there. We're gonna talk briefly about the sine and cosine sum and difference formulas, verify them, see how they work, and end it there. But the reason these are important, what we talked about in class is, let's say you have sine of 30 degrees. Well, 30 degrees is on our unit circle. 45 degrees on our unit circle. 60 degrees on our unit circle. Let's leave a space there. Sine of 90 degrees on our unit circle. We're trying to identify the pattern, and what we talked about is if you start here, you're adding 15 degrees each time. And so this would be sine of 75 degrees. Now, what we talked about is here, this one there, it would be great if we can calculate the exact value of this. We don't know that because it's not one of the prominent values on our unit circle, but the idea is that we can try to figure out a way to calculate this. That's what these formulas are going to help us do. We'll see that after we talk about them, but these formulas help us do that. So if you have a pen, pencil, definitely have it nearby. Here, this is alpha and beta. If you want x and y, whatever you want there, that's fine. But in the formula that you might get for your challenge exam, it's going to be alpha, beta. So if we add alpha, add or subtract to beta, then we do plus minus here, cosine of alpha, cosine beta, or sorry, sine beta, excuse me. Now, half the battle is actually reading it, understanding what this is saying. What this is saying is if you have alpha and you add it to beta inside here, then this entire formula stays the same. Sine alpha, cosine beta, cosine alpha, sine beta. But since we're adding, and adding is on top here, we have to look here and see what's on top. Well, for sine, it's still addition. What's on top of the plus minus. So it's plus. If it was sine of alpha minus beta, notice minus is on bottom here. That means here we have to look. Since it's plus minus, minus is on bottom, it'll also be minus there. Now, if you were not here for this day, we're going to get better with this plus minus stuff because it's going to come up a lot. That's how you would read this equation or this formula. Same thing here. Let me do the divider lines. Cosine of alpha plus or minus beta. What we would do is cosine of alpha, cosine of beta. Now, where sine is plus minus, this one is minus plus sine of alpha, sine of beta. And so what this is telling us is if you have cosine of alpha plus beta, and this would be cosine of alpha, cosine beta, this formula does not change. However, since the addition is on top here, we're using addition. Since the addition is on top here, we use what's on top here. So this would be minus sine alpha, sine beta. Similarly, if you do cosine of alpha minus beta, this would be cosine alpha, cosine beta. Again, the minus sign is on bottom in this thing, if you will. Positive sign is on bottom here, so it's plus sine alpha sine beta. And the tangent formula is here. Now we're going to get some practice with tangent eventually, whether in this video or next one. But notice here it's positive, negative. In the numerator, it's positive, negative. However, in the denominator, it's minus positive. So we just need to be careful there when we're using tangent, even cosine and sine as well, as we'll see soon. If you need to pause it, go back, so make sure you understand how to use these formulas. That'd be great. But now what we're going to do is we're actually going to verify these values. So we're still dealing with trigonometry. Anytime you're dealing with trigonometry, might be good to have a unit circle nearby. So we're going to use this formula to verify sine of 90 degrees. Well, we know if you look at the unit circle, 90 degrees is where pi over 2 is, and sine of pi over 2 is 1. So our answer should be 1. That's what we should get. We're going to use this though. So what we're going to say is we want 2 degree measures that if we add them together, we would get 90. Now the ones we did in class mainly were 60 and 30. If you add 60 and 30, you get 90. So what this means is sine of 90 degrees is equal to sine of 60 plus 30. Well, now that we have addition inside of our sine function, we can use this formula here. So if it helps you to write it out, I'm going to use a different color. Think of 60 as your alpha and 30 as your beta. And since it's addition, we'll actually use this first one here for sine. So this would become sine of 60 degrees cosine of 30 plus, since the addition here, addition's on top, plus cosine alpha is 60 sine 30. Now what we can do is say, okay, now we can go to our unit circle and figure out what each of these values are. So if we wanted to figure out what sine of 60 degrees is, in terms of radians, 60 degrees is pi over 3, and sine at pi over 3 would be square root of 3 over 2. Cosine of 30 degrees is equivalent to pi over 6 in radians. So cosine of pi over 6 would be 1/2 plus, and then similar thing, cosine of 60, we're looking at pi over 3, cosine is x, that's 1/2, times, my apologies here, cosine of 30 degrees is actually square root of 3 over 2. That is my fault. And sine of 30 degrees is 1/2. Now, when we multiply fractions, multiply straight across, so square root of 3 times square root of 3 is 3, because you do like this. 2 times 2 is 4. 1 times 1 is 1. 2 times 2 is 4. Now to add fractions, what we have to do is find a common denominator. We already have that. 3 plus 1 is 4. 4 over 4 equals 1, which is what we wanted. All right. So it works. The sine formula works. It's valid. It's something that we can use. Cosine of 120, we're not going to go through it. Cosine, the 120 degrees in terms of radians is 2 pi over 3. And cosine at 2 pi over 3 would be negative 1/2. So using this formula, you should end up with negative 1/2. Now in class we talked about what degree measurements add or subtract to 120. Some things you could use, I would highly recommend going through it, making sure you get negative 1/2. You could do 90 plus 30. You could do 180 minus 60. You could even do 60 plus 60. Any of these we could use that there and simplify, hopefully using the formula back up here, hopefully end up back at -1/2. Try that on your own, see what you end up come up with. Make sure you get -1/2. If you don't, please email me, let me know, and I can point out your errors. But I'm going to stop this video here. On the next video, go to the next page, see how we actually will use this, see how it might look on an assessment or a challenge exam.